Alright guys, we're going to look at solving absolute value equations and inequalities algebraically. That means you are not using a calculator for this. Now, a great thing about my absolute value, it takes anything and turns it to a positive number. So anything that I put in here inside that absolute value, if it ends up as negative, I'm just going to turn it to a positive. That's going to give me a couple of solutions on some things, really pretty much everything that we do on this. So you'll start to see some similarities to our conjunctive and conjunctions and disjunctions that we did as we graphed inequalities. So looking at this first one, x, the absolute value of x is equal to 4. So knowing that if I just put a 4 there, the absolute value of 4 is 4. So my first one that I'll have is x equals to 4. Then if I put a negative 4 in there as well, x can equal negative 4, and the absolute value of that is going to end up as 4. So really what you're looking at is when you have a number line, if I put 0 in the middle, you'll start to notice that everything we do is kind of centered around how far away that is from the 0. So just looking at my basic ones here, if I have positive 4, and I'm not drawing any arrows here because this is just an equation, not an inequality. Then I also have negative 4. Both of those the same distance away from my 0. So my absolute value there giving me the distance that it is away from 0. Now, as I add some equations into here, I'm going to look for two things. I want either my equation in here to equal positive 10 or negative 10. So again, that absolute value is just saying how far away have I gone in either direction. So we'll start out with 3x plus 4 equals 10. And then our other option is going to be 3x plus 4 equals negative 10. Because if I get an answer of negative 10, that absolute value just turns it into a positive because it's saying that that number is 10 away from the 0. Doesn't matter which direction. Starting out here, subtract 4 from both sides, doing our usual solving of a linear equation. Divide by 3, and I get that x is equal to 2 for this one. Next one, I'll take the positive 4, so I need to subtract 4 from both sides. Cancels out. So 3x equals, now if I'm subtracting two negatives, I'm going to add them together. They'll be more negative, so it gives me a negative 14 because I'm moving back to the left. Then I can take and divide both of those by 3. Cancels out. X equals negative 14 over 3. So looking at and I should have done this first, looking at my preliminary, what that means is my two answers. So once I've solved everything inside that absolute value, what are my two options? And those were 10 on that side and negative 10 on that side. Then what I'm really looking for is that answer of what is x going to be equal to that gets me to that 10 or negative 10. I'll keep my 0 there. First one was x equals 2. Put that there. And then my next one, x equals negative 14 over 3. So putting that one a little further away because I know that's a little more than negative 4. But again, we are just leaving it as that fraction since we are solving it algebraically. This is an accurate representation of that number, more accurate than even if you put it in the calculator, you'd get something since it's thirds with the 3 repeating. So this allows us to have an exact answer there. Okay, looking at the next one, I'll do my preliminary first. So with 0, if I go 2 away from that 0 in either direction, it would be a positive 2 or a negative 2. So it's like walking to class. It doesn't matter which direction you've gone. You're just deciding how far it is that you went. Positive or negative, left or right, doesn't matter. That's what the absolute value does for you. So then I'll go to solving my equation. I can have 13 minus 5x equals 2, or 13 minus 5x equals negative 2. Okay, solving that out real quick. Negative 5x equals it'd be negative 11. Then subdivision, divide by negative 5. And again, doesn't work out evenly, so I'm going to leave that as 11 over 5. Positive 11 over 5, because a negative divided by a negative would give me a positive. Then working out for my negative 2, subtract 13 from both. This time I get negative 5x equals negative 15. When I divide those out, I do get a whole number, so we're going to change that. Instead of negative 15 or 15 over 5, we'll just change that to 3 because I know 3 times 5 is equal to 15. Okay, so those are both positive, and just the way it works out within the equation. So my only thing there is going to be deciding, well, this was 15 over 5, that was 11 over 5. I'm going to make sure that I put 11 over 5 there before or in front of my 3, because again, the whole thing we're looking at here is distance from 0. Okay, let's look at one of these inequalities. So when I've got an inequality, now I need to know this, whatever value here needs to be less than or equal to 8. So as I put in my preliminary, start out with my 0, and anything, so if I say I can make it to class if I have to walk less than 800 meters, I'll make it in 5 minutes. You might do something like this. It doesn't matter which direction, it just matters how far you're actually going. So first one here would be an 8. Then I'd have a negative 8 here. But it says I need whatever this absolute value is to be less than 8. So this is where we get into what actually looks like one of our conjunctions that we've done, because if I go 7 to the left, that's still less than 8. If I go 7 to the right, it's still less than 8. So any number of those in there works. As I solve that out, since I know this looks like a conjunction, I'm going to work it as a conjunction. So negative 8 is less than or equal to 3x minus 4, which is less than or equal to 8. Now remember, if you're drawing lines to solve, we do one on either side. What that means is, so remember, I need to take and add add 4 to the middle here. When I do that, I've got to add 4 to both sides. So 8, 9, 10, 11, 12. Negative 4 plus 4 cancels out. It's 3x. And then 8, 7, 6, 5, 4. It'd be negative 4. Now you might be looking at it and saying, well, wait a minute. It says that this should be, whatever it is, should be less than 8. But over here it says greater than. That's a lot of the reason why we do this, because if I said this value was less than negative 8, less than negative 8 actually travels down this way and would give me an absolute value that's larger than 8 overall. So I need all the numbers that are bigger than negative 8 and smaller than 8, which is why we do it this way. Last thing I need to do here is divide all 3 portions of this by 3, which leaves me with, and I'm dividing by positive, this negative has stayed over here, hasn't moved at all. So, I'm running out of room here, but I've got x is less than or equal to, turns into a 4, and that doesn't go out equally, so I'll leave it as negative 4 over 3. Putting that on my graph here, I'll always put my 0 there. And I need a positive 4 there, and a negative 4/3 there. And again, since it's an inequality and a conjunction, I'm going to fill in that part right there. Okay, looking real quick at, look at one on the back, just as we have time for. So when we're looking at this, so I need something that is greater than 14. So I want you to think, if we're looking for a greater, that's going to be the or the disjunction. Okay, because on my preliminary, let's put a 0 there. I know that if I put 14 there, I need anything that's greater than 14. Remember, I've got my open dot. So bigger than 14 is going that way. But I also need down here a negative 14. So to be farther away from the 0, also going to go that way. So I will work this out, same as my equalities there, as 2 separate equations. So I have 6 minus 2x is to be greater than 14, or, this is where I'm going to look here, all these numbers would be less than negative 14, so I'm going to write this as 6 minus 2x is less than negative 14, because that gives me a larger negative number, which puts me, as it's an absolute value, turns it into a number that's greater than 14. Work these out real quick. Subtracting 6 on both sides gives me negative 2x is greater than 8. Now, I'm going to divide by a negative. So when I divide by that negative, that's when I change my sign. Those cancel out. 8 divided by negative 2 gives me a negative 4. Do the same thing over here. Subtract 6. So that is negative 20 greater than negative 2x. Again, dividing by a negative. So I'm going to change my sign. It says x is greater than, and that ends up as a positive 10 because I'm dividing negative by negative. Now I'll just put those on here. I need my 0, negative 4, and 10. Those are going to be open circles. And that stays as a disjunction. It says x should be less than negative 4 or greater than 10. Okay, so something you can always do, especially when you've got a quick and easy equation like this, if I take and put in negative 5, for instance, to this, so 2 times negative 5 would give me, or that's a negative 2 times a negative 5 would give me positive 10 plus 6 is 16, which is greater. So putting in an example over here works. It'd be the same if I did it over here as well. Okay, hopefully this helps. Good luck on working through the rest of it.